For years, astronomers have watched one of the brightest and most mysterious stars in our night sky, Betelgeuse. A red supergiant resting in the shoulder of the Orion constellation, teetering on the edge of collapse. Scientists knew the end was coming, but no one knew when. Now, the James Webb Space Telescope has captured something no one was sure we'd ever witness in real time. The beginning of Betelgeuse's explosive death. A stellar cataclysm, a cosmic shockwave, and a breathtaking display of the raw, violent power of the universe itself. This isn't just another deep space observation. It's a once-in-a-lifetime cosmic event, the closest supernova humanity has ever recorded. And what Webb saw has changed everything. Betelgeuse is no ordinary star. It's a red supergiant, more than 700 times the size of our Sun and about 20 times more massive. For decades, astronomers tracked its instability, massive surface storms, unpredictable dimming, and unexplained outbursts of plasma. In late 2019, Betelgeuse dimmed dramatically, sparking global speculation. Was this the moment? Had the countdown to supernova finally begun? Now, with the unmatched infrared vision of the James Webb Space Telescope, the mystery is finally unraveling. For the first time, humanity is observing the real-time collapse of a massive star. The data reveals extraordinary turbulence, vast convective cells shifting violently, bursts of energy ejecting from its core, and magnetic fields twisting into complete chaos. Betelgeuse isn't just dying. It's transforming, before our very eyes. For months, Webb has watched, peeling back layers of stellar atmosphere that no telescope before it could penetrate. And now the images and data are in, and they're astonishing. We can see colossal bubbles of hot plasma, the size of Jupiter, rising and bursting on the star's surface. Plumes of gas are erupting into space at velocities too extreme to fully comprehend. Even more compelling, hidden within the light spectrum is a shockwave, an expanding pulse of energy racing through Betelgeuse's outer layers. For the first time in history, scientists are witnessing the death of a massive star, not in simulation, but in real time. And it's happening just 642 light-years away. Unlike the distant supernovae we've observed in galaxies far, far away, Betelgeuse's impending explosion is happening close enough that, when it reaches its peak, it may be visible from Earth even during the day, outshining the full moon. But beyond the visual spectacle, its proximity offers something even more profound, an unprecedented scientific opportunity. A front-row seat to study a dying star with detail never before possible. We are observing the collapse of its core, the fusion of heavy elements like carbon, oxygen, and iron, the very building blocks of planets, oceans, and life. What Webb has captured is not just destruction, it's creation. This is the process that seeds the cosmos with the elements that make us, us. We are witnessing the origin of life in reverse. Betelgeuse's death is more than a cosmic finale. It's a key, a window into the hidden processes behind galaxy formation, star birth, and planetary evolution. With Webb's extraordinary sensitivity, we can now model the final stages of stellar life cycles with unmatched precision. For the first time, we understand the signs to look for when other stars approach their own collapse. This isn't just science, it's revelation. A moment where humanity has peered into the heart of time and watched it tear itself open. But the explosion doesn't stop with light. It unleashes shockwaves that ripple across interstellar space, disturbing the medium around it. Already, Webb has detected high-energy particles cascading outward, heating nearby gas clouds and distorting Betelgeuse's enormous dust halo. And there's something else, something unexpected. A gravitational ripple. Despite the distance, 642 light-years, Betelgeuse's collapse may have generated gravitational waves, subtle distortions in the fabric of spacetime. If confirmed, this would be a historic first, the first time a visible supernova has been directly linked to gravitational wave detection. Such a breakthrough would redefine our understanding of how matter, light, and gravity interact in the most extreme conditions known to nature. As Betelgeuse implodes, an ancient question returns, one of the great unknowns in astrophysics. What's left behind? Will it become a neutron star? A black hole? Or something stranger? Early data from Webb shows troubling asymmetries in the collapse. Magnetic field disruptions. Voids in the plasma. Even signs of a fallback effect, where some of the ejected material is not escaping into space, but being pulled back inward by gravity. This hints at something scientists have only theorized, a possible transitional object. A state between neutron star and black hole. If Webb has captured such an object forming in real time, it would be the first observational proof of a new class of celestial body. A discovery that could reshape astrophysics forever. With a supernova this close, people naturally ask, are we in danger? The short answer, no. Earth is safe. Betelgeuse is far enough away that its radiation and shockwaves won't harm us. But the long answer is more nuanced. This explosion will release gamma rays, cosmic rays, and radiation that will ripple across space for centuries, affecting nearby star systems, reshaping interstellar dust clouds, and potentially altering the path of light from other galaxies that we observe. In this way, even from across light years, Betelgeuse's death will subtly, but permanently, reshape our view of the universe. Betelgeuse is massive, ancient, powerful, and now, it is dying. A reminder that even the stars, the timeless sentinels of our sky, are not eternal. What Webb has captured isn't just the death of a star. It's a mirror held up to the universe and to ourselves. Everything that lives must end. But in those endings, new beginnings emerge. From Betelgeuse's ashes, new stars will be born. New planets may form. This is not just destruction, it's cosmic renewal. And we were here to witness it. Among the vast data streaming from Webb, scientists have discovered something even more remarkable. Rare elements in the ejected material, technetium, yttrium, and other exotic isotopes that are only created in the hearts of dying stars. Why does this matter? Because by studying these elements we can trace the full journey of matter, from stellar cores, to interstellar dust, to the atoms in our bodies. Webb isn't just watching a supernova. It's decoding the chemistry of life. And Betelgeuse, in its final moment, is telling a story that began long before Earth even formed. Soon, Betelgeuse will disappear from Orion. In its place, an expanding nebula of gas, dust, and glowing particles, a supernova remnant that will linger for thousands of years. But its death is not the end. It's a gift. A gift of knowledge, perspective, and wonder. A reminder that our own sun will one day follow the same path. That even the brightest stars burn out. And that from their remains, new stars, new worlds, and new life can rise. Because without supernovae, there are no planets. No oceans. No people. Thanks to the James Webb Space Telescope, we are witnessing, clearly, for the first time, the full stellar cycle. From the swelling of a giant, to its fiery collapse, to the creation of the next generation of cosmic building blocks. In the silent cold of space, 642 light-years away, a star has ended its life, not with a whisper, but with a final, brilliant roar that traveled through the darkness of time and reached us. And this time, we didn't just see it. We understood it. Betelgeuse did not die in vain. In its final breath, it gave us answers to some of the oldest questions in existence. Where do we come from? How do stars die? And what happens next? In that fading red light, Webb has captured not just the death of a star, but our origin story. And maybe, just maybe, a glimpse of our future. So now we ask, what else is the universe ready to show us? And are we truly prepared to witness it? Let us know what you think in the comments. Was this the most important stellar event of our time? And what other cosmic secrets might the James Webb Space Telescope uncover next? Subscribe and turn on notifications. Because this isn't the end. It's just the beginning of what comes after the stars.